Well, good morning, good afternoon, good evening to wherever you may be across this absolutely lovely world. Thanks so much for joining us here live for Serverless Office Hours. And we're streaming on the AWS Twitch channel and YouTube Serverless Land and also LinkedIn Live. My name's Julian Wood. I'm a developer advocate for Serverless at AWS, and I'm joined by a cast of SaaS experts. Just going, I suppose, underneath me, top and left. Anton, how are you? Welcome to Serverless Office Hours. I think it's your first time, even though as such the expert you were, I'm slightly embarrassed that we haven't had you on before.
Hey, Julian. Yeah. That's my first time owning the actual session, right? I've joined a few times before as a co-speaker, but this time we're going to be actually leading this. So thanks for having me.
Excellent. So how long have you been at AWS, and what's been your journey
Uh,
to what you're doing now?
it's getting close to 18 months now, right? About a year and a
Wow.
half, right? So yeah, I joined right away as a serverless solution architect. Uh, One of the reasons I wanted to do serverless is because I've tried multiple non-serverless ways before, and I wanted to get into something new, something that will actually help me to focus more on application, right,
Yeah.
and less on managing infrastructure. So that was a very interesting new field for me. I wanted to get completely out of my comfort zone. I've been dealing with cloud for probably as long as I can remember, right? Maybe like 10 years. I worked for other cloud providers. I worked for companies that build cloud services, right? So getting into this serverless solution architect role was very exciting for me. So,
Excellent. Well, welcome. Yeah, Todd, you're a very senior title. You're not you even senior principal. So, yeah, tell us about being the SaaS tech lead, and yeah, what does that involve, and how did you get to AWS?
Yeah, I guess I've been here a little while. I guess total time at AWS has been like 9.5-ish years.
Wow. So that's like
Started
100
out
years in
in like
normal years.
the seventh person in pro serve, and then left and came back in the role that I've been in like 7+ years. And when I showed up, there was we were sort of just getting our arms around what it meant to sort of give prescriptive guidance around SaaS and figure out what it was. So and as part of that, we built out a team, SaaS factory team here at AWS that works with customers and partners who are building, delivering, optimizing SaaS solutions on AWS. Anubhav, who you'll hear from here shortly, is part of that team as well. And I also lead sort of a global technical community at AWS that focuses on this. And we actually have a Show Me SaaS Twitch show we do as well. So and a couple other Twitch places. So maybe a little bit of shameless cross promotion there going on.
Absolutely. More the merrier.
Yeah, so been in this space, just love the SaaS space, kind of worked on it on my own outside of AWS, and have been fortunate to run into folks like Anton and Anubhav and generally like serverless technologies, which have been a huge sort of a value add for the SaaS side of the world, and sort of aligning sort of the business and the technical needs in interesting ways. So I'm really happy to be here. Thanks for inviting us to join.
Pleasure. Yeah, and Anubhav, I think you've been partly introduced, but I've always loved the idea of a SaaS factory. I think when I've seen that term from AWS, I think that is a cool team to be on.
And I was fortunate enough to join it in a pretty early stages, I would say. I've been here for about 4 years now, and have been working with Todd closely since last 4 years. I can't believe it's been 4 years, Todd, by the way.
I know.
Time flies. And yeah, I come from an application development background mostly. And previously I've built software solutions as a lead architect for many startups and enterprise roles, right? And then when I joined AWS, what I really like about this role is the ability to kind of build, right? So we kind of build a lot of reference solutions for our customers, which one of them we're going to talk about today as well, right? So yeah, I'm really excited being here as well. Thanks for inviting us, Julian.
No, pleasure. Well, just before we get back to the awesome SaaS people in AWS, yeah, I'm just going to look back over the past week of things that have been happening. Last week's stream on the 7th of Feb, visually design and build serverless applications. So this was going through the new feature that was announced at reInvent under preview, AWS Application Composer. Basically drag and drop and build a serverless application. So yeah, really good walkthrough by the product manager, Ryan Coleman. So have a look at that. That's on the youtube.com/serverlessland, as with all our other serverless office hours episodes. Some things that are new that have been coming out. Just the top one, Lambda has, if you're doing asynchronous Lambda invokes, some new metrics which are useful. So this can tell you if you have any delays as messages are going through the Lambda service when it's handling things for you, and this can highlight some throttles and things like that. So that's really good. Also SNS, X-ray. People love tracing. Of course, you want to do tracing to be able to, as you're building these distributed serverless applications, tracing is super important to, as it says, visualize, analyze, and debug app performance. And SNS is even getting better at X-ray tracing, which is helpful for everybody. Some interesting blog posts. The top one from Arti and Dheeraj, talking about those invocation metrics and how you can use them. Then also SAM pipelines. This is an OIDC. So previously for SAM pipelines, if you're unaware, basically builds the scaffolding for building CI/CD pipelines for your serverless applications. And previously it needed the secret key and the secret keys to be able to connect back to AWS to authenticate. Now you can use OIDC, which is short-lived credentials, much more secure, much simpler. And so, Brian and Raman came up with a really good blog post to talk about that. And the last one from Dominic Richter I'm going to talk about is just architectural patterns for event bridge pipes. So Amazon Event Bridge has event buses and also has pipes. Pipes is sort of the Unix philosophy pipes. Take an input, do some transformational work on it and send it somewhere else. Event bridge pipes make that really easy at cloud scale. And Dominic's got some really interesting architectural patterns to help with doing all of that. So really good stuff. I will mention the next one down actually, because that also was really new. Serverless Espresso has been one of our demo applications for talking about building event-driven architectures, and that is extensible. You can actually add your own modules to Serverless Espresso to do cool new things. And Cornelio built one in 24 hours, and he put it all together and released it as open source. And so he's also written a blog post, and the bigger picture is how you can extend serverless applications that are built in an event-driven way in a simple way. So really have a look at those. But bring it back to this week, multi-tenant serverless SaaS. So I think I'm going to tie this up with originally is, what is so special about SaaS applications? And I'll head over to Anton to tell us more.
So SaaS applications are interesting, right? And if you ask me or Todd or Anubhav, right, we might even have interesting and different opinions that actually complement each other. What's interesting about SaaS applications, which stands for software as a service, right, is usually they come with multi-tenancy in mind. Okay, so when you're building a solution as a service, something that you want to put on cloud and you want many of your customers to consume that, you're building a product that will be reused by multiple customers. Okay, now we'll be talking about different models of implementing SaaS in detail today, right? But the idea is you can take the, let's call it legacy or classic model of running software on-prem, where you have a deployment that you create for your customer, and you can take it to cloud, right? You will already see some benefit of that because you're running on cloud and you're managing significantly less infrastructure right now. But as you move a little bit more towards that cloud native spectrum, right, the other side, where your solution is not deployed per customer, but you're actually having some shared components, some multi-tenancy built in. This is where you're starting to realize, the benefits of cloud. Okay, that's where you're starting to realize all the benefits of, cost optimization, of performance, et cetera, et cetera. However, it also brings us interesting challenges, right? Challenges like isolation, right? Challenges like how do you properly decide which components can be shared, which components cannot be shared, etc. So to summarize this, right? SaaS applications are a little bit special, right? And one of the key reasons they're special is you do need to understand more, about multi-tenancy when you're building those applications. Consider multi-tenancy.
Yeah,
So
I would add on to that.
Carry on, Todd.
I would just add on to that, and that's I totally agree with what Anton said there. For me, I think a lot of the motivation and the value of SaaS and why there's so much sort of momentum around the move to SaaS here is that if you look at the sort of traditional way that software is built and operated and delivered, and there are a lot of parallels to this in the cloud's evolution on its own, is that people who sort of built and sold software in an installed software kind of mode where every customer got their own copy and customers are running different versions, and that all works up to a point. But then there's like the economies of scale of that start to really be a struggle, where like if everybody's running one-off versions, we have to have separate operations teams. We have to have all these, like, how do we innovate? How do we move faster? How to release quicker? And what happened is that as SaaS providers came into this space where all customers were run through a single sort of pane of glass and operated and managed collectively, those providers could release really quickly and innovate really fast. And this really became a huge sort of competitive advantage for different providers, right? And so this notion of sharing infrastructure, having a single deployment for all customers, having a single management experience represented efficiency, cost efficiency, operational efficiency. And that's really the thrust of what SaaS is all about to me, which is taking your business from maybe a sort of one-off bespoke sort of model to this, hey, we're going to have this one machine of innovation and speed and bring our customers with us. And I see parallels to that in the cloud where, you get the benefits of the cloud from our ability to innovate and evolve our services at a rapid pace, and everybody gets the same thing. Everybody's managed, operated through one unified experience.
Can you sort of tease out for me some of maybe the distinction where SaaS needs to be multi-tenancy? Because some SaaS products would just be, I've got a whole bunch of different customers who are now accessing my service over the internet. Is there a distinction between the SaaS part of it and actually being multi-tenancy? All SaaS providers have to be multi-tenancy? Because in my mind, multi-tenancy means a bit more security, that you've got two companies who may be competing. You've got Amazon Prime and you've got Netflix running on your infrastructure, and you need to be very cautious that you are, separating from a security perspective their different workloads for, governance or legal or those kind of things, rather than, I'm just running my service over the internet.
Yeah, this is one of the areas that is always a challenge. And we've spent a lot of effort and energy putting language around how we describe SaaS environments, because there's a lot of sort of legacy terminology that's attached to the word multi-tenancy, right? You're running in the cloud, you are running often in a multi-tenant context. Your workloads are running alongside one another. And the traditional sort of definition of multi-tenancy was this infrastructure rooted sort of notion in multi-tenancy of saying that we're both sitting in some piece of infrastructure side by side. But in a SaaS environment, there's elements of it that do map to that infrastructure, shared infrastructure model. But the notion of multi-tenancy is, and we've intentionally done this, is we've broadened that definition of multi-tenancy and said, in a SaaS environment, we're saying that you are running and operating all of your tenants side by side. And then the degree to which those tenants share infrastructure or not depends on your business model. We have people who are, we'd call multi-tenant, who have almost no shared infrastructure, but they're still deployed the same. They're still managed through one cloud class. Every customer gets the same version. And then there's other customers who share parts of their system on infrastructure, but then leave other bits siloed. In fact, we'll get into this terminology of siloed and pooled, and we intentionally use those to get us away from the term multi-tenant, because we feel like if you're a SaaS provider and you've adopted this mentality, you've got a multi-tenant system. And then, yes, when we go under the hood, we'll talk about where or if you might have shared infrastructure or not.
Okay, so the bigger picture is to say that SaaS is a bigger umbrella term, that you are providing software as a service or something over the internet. And underneath that, yes, you may have some silos, some pools, some multi-tenancy to be able to deliver that. But the terms are not interchangeable, because one's a subset of the other.
Yeah, I think we have run into this when we talk to security folks all the time, because we'll talk about multi-tenancy and it's all about like, how are you isolating all the way down at this level? But we have to isolate a level above that, because we have notions of isolation that aren't at the infrastructure level. They're at the application level. And so our notion of multi-tenancy becomes an application construct sometimes, not just an infrastructure construct. And so that sort of changes the whole mental math of all of this. And so I think of SaaS, the experience you're trying to deliver and the operational model you're trying to deliver. And then the next layer of detail is like, what's siloed, what's pooled.
Okay. I mean, do you want to go through some of the different tenancy models?
Sure. And I can share a little, I don't know if I'll try to share a slide here. That might help. We'll see. Let's share my screen.
Yeah, I just jumped into the question. If you want to do it in a different order.
No, that's totally fine where you went. I'm just thinking if I can make a slide that helps with this, or show a slide that helps with this. Let's go.
Let me let you get your slide up before I
it's up.
bring it up on the screen. Excellent.
It's up. Awesome. Oh, echo. Anyway, so almost all the terminology we've adapted here were intentionally, like I said, to get us away from this notion of the word multi-tenant. And so across almost all of our discussion of SaaS deployment models, whether we're talking about storage or we're talking about compute or whatever we're talking about, we talk about it through this notion of silo, pool, and bridge as the three sort of flavors of this. And silo it really is meant to be that a resource is dedicated to an individual tenant. And that could be the entire stack is dedicated to the tenant, or it could just mean a particular resource is dedicated to an individual tenant. So that term spans all flavors of experiences. Just dedicated, if it's dedicated, it's siloed at any layer in the architecture. And of course, pooled is sort of the more classic notion of what most people think of when they think about multi-tenancy, because pooled is really saying that a resource is shared by multiple tenants. And I think this is most people, when they think they're going to SaaS, they're going to the pooled model. In fact, pooled is the natural place we want to point people, because that's where you get the best economies of scale, right? When we're on the silo side of this, you aren't, because you're not sharing infrastructure, there's a higher operational cost, there's more complexity in those systems. But in reality, both models exist. And I would even say silo and pool can exist in the same SaaS experience. You might offer a basic tier tenant a pooled experience, and you might offer a premium tier tenant a siloed experience. In fact, when we get to Anubhav and he starts talking about our reference architecture here, you'll see that he's actually implemented that exact model through a serverless scheme. And then bridge is just here as the term to sort of denote the fact that you're a mix. You could be a mix of those things, some resources siloed, some pooled. So those are the terms we use to describe this. I don't know, Anubhav, if you have anything, or Anton, you want to add to that?
No, I think you kind of covered it very well. I mean, obviously, silo means dedicated resources, and you can implement it in multiple ways, like by creating multiple accounts, multiple VPCs. There are different ways how you can implement, or multiple clusters, right? And pool model is where you can definitely use some application level constructs to isolate tenants within that same shared infrastructure, right? So that's the kind of high level model. And then there's a line in between, which could be like, you can have separate queues, maybe a single compute, separate databases, single compute. So many variations that you can't really kind of pin on something specific, but that's the high level gist of it.
And it's important, right? So this is a decision that you will need to make at some point when you start to build your architecture, right? So, as you're imagining your new SaaS system, right? Analyze what you're trying to build, analyze what would be the requirements, right? Work with if you have a security team, work with your security team to understand what's acceptable from their perspective, because we all know that while it's hard, it's still possible to argue with security teams, right? So analyze what's acceptable from their perspective, right? And then examine your stack, right? Because this siloed or pooled approach, it can be applied at multiple levels, right? That's the reason we call it stack, right? It can be as simple as, so do you have a single DNS entry point for your tenants, right? Like www.mycompany.com, right, /API, or do you actually provide a standalone DNS name per tenant, right? And it can start at the very top, it can go all the way to the bottom. Let's say data storage, right? Do you use one S3 bucket per tenant, or one bucket for all of them? Do you use a single database for all the tenants, and you encrypt data with tenant specific keys, right? Or do you actually have split databases? All of these options, right, they give you different flavors, and more components you have along the way in your stack, obviously more decisions you'll need to make there, right? But the principle is the same, right? Isolation on each one of those levels, and get to a point where you're sharing as much resources as you can to achieve the optimal cost, right? But also addressing all the security requirements.
Yeah, and I think it would be good to kind of classify that SaaS is a business model, right? It's basically a way to do business. So there are so many business considerations that kind of weigh into these architecture choices, right? You might be dealing with some sort of compliance requirements, so where you have different businesses that require that tight isolation. You need to separate out the database into separate RDS instances, or maybe separate Postgres databases. There could be like noisy neighbor SLA kind of scenario playing in, where you want to make sure that you have promised, let's say 99.99 SLA to your customer. Like, how would you make sure that you achieve that, right? In some cases, you just can't control the concurrency, right? You just can't really throttle them, and the only option is that to kind of scale them across multiple accounts. So there are so many factors that kind of goes into this. You might have different tiering strategies, again going back to your pricing plans, right? So again, the decision is not just based upon security, but again based upon various business requirements as well, I would say.
And I did have one more screen to share here, Julian, if you could throw that up. 'Cause I actually feel like this is one of the most important slides I have that sort of connects this whole deployment model to how you design your application, because this sort of bleeds over into what does it mean to design my microservices, and when I'm building the microservices of my serverless solution, where are the boundaries and how am I going to apply these silo and pools? And I use this slide just to drive home the point that how granular this silo pool decision really is, right? So if you look at this from left to right in this slide, you'll see I have this order service where I've actually have siloed instances of the compute here, but they're both sharing a pooled representation of the data. And then you move over to my product, you've got pooled compute and pooled storage. Then you move over to my invoice, I've got pooled compute, but siloed storage. And then this applies all the way across, separate queues per tenant, silo or pool, and so on as you go across. And what we're really encouraging people to do, and Anton was kind of touching on this, is you're not just deciding we're silo or we're pool at some big high level sort of bit of your architecture. You're thinking about this on a microservice by microservice basis, and you're evolving over time. Like something that might be noisy neighbor tomorrow that wasn't today might suddenly get siloed because you needed to be siloed. Maybe some storage suddenly has a higher compliance threshold with your customers, so you move from pooled to siloed. So you're continually reevaluating where you apply this silo pooled mindset.
Okay. Yeah, and of course, remember we're live, so please send us in your questions or comments. And in fact, Angelo, thank you for joining us via YouTube. Yeah, how do we know when a multi-tenant architecture is right for our application?
Well, that's a tough. I'll talk too much here. So if somebody wants to jump in ahead of me, go ahead.
I mean, I would say it's based upon your use case, right? And there is no one definition. You can't really say that pool model will work for you or silo model will work for you. It kind of depends upon your use case, your business SLAs, your noisy neighbor footprint, your architecture, and how have you implemented your throttling mechanisms, right? That's kind of plays into this as well. So normally when we kind of talk to customers about deciding the multi-tenancy, we kind of go through all these questions, right? How do you plan to isolate your tenants? What are your requirements around multi-region? What are your requirements around isolation, compliance requirements? And then we go into the architecture details, and then we kind of decide what is the right level of multi-tenancy, right?
Yeah, and I would say that the question is really not whether you want to be multi-tenant or not. This is back to what is SaaS that we had at the beginning. Is SaaS the right model for you to sell your software in? Is that the right business model? Is that how your customers come with you and they consume it that way? Is it fit with the strategic model of your business in terms of with the value you're going to get out of this, right? Because investment in building a multi-tenant system is not small. So if you're going to go down that path, it has to be connected to a business story where you're saying, hey, we're trying to capture new markets. We're trying to capture new customers. We're trying to lower our operational costs. And we're willing to trade all these economies of scale of SaaS for the ability to maybe offer different customers one-off customizations and so on. So you ask that question at the business level, and then once you've decided the SaaS business model fits for you, then inside that you start saying, well, what's our multi-tenant story for SaaS in our particular environment?
And I suppose you need to come in it. You need to be intentionally multi-tenant. I think you wouldn't start to be in a multi-tenant architecture for all your customers without having a business requirement to do that, because multi-tenancy takes some work. If you are just running a website over the internet, you don't need necessarily strict tenancy. And I think Robert Tables, thanks for joining us via Twitch. Yeah, customers requesting white label and customizations is a good case for multi-tenancy. Yeah, so potentially, I would say if that's going to make you more money and that's a business driver that you want to give your customers white label and customization, maybe multi-tenancy is a way to walk.
I think the customizations part of that one is a little bit of a slippery slope, depending on what you mean there, right? Because some people think I'll go multi-tenant, but we'll go crazy with feature flags and other mechanisms to try to offer all these one-off versions to different customers. And if your like whole motive is to truly offer one-off versions to your customers, and you're just like sort of just filling your system with all this customization to achieve that, to make it all one deployment, there's a point of sort of diminishing returns there where that isn't a good fit. Some customization's good, but it, like, generally SaaS isn't motivated by the desire to introduce customizations. It's motivated by the desire to get scale out of offering a single experience to everybody, and then acknowledging that, yeah, there'll be customization under the hood, and hopefully tiering and other mechanisms will support that. But the story we would always say is you'd never do something that was for a customer. You do something that maybe only one customer is using, but you introduce it in a SaaS environment in a way that any customer could benefit from it.
So, I mean, the question about feature flags, just quickly about the feature flags, and I'll come back to you, Anton. I mean, if somebody says I'm doing feature flags, and so I'm multi-tenancy, to me that doesn't sound as though that's the same thing. My understanding is multi-tenancy is quite a bit more deliberate segregation of your tenants, rather than just feature flags to give my premium shoppers free delivery, for example.
Exactly. Yeah, the motivation to be SaaS is that you are mostly focused. In fact, you're focused on trying to share infrastructure if you can, and share the operational experience, and have this one unified view into everybody's experience. And the feature flags just end up being a way to solve a few problems within that environment, and they should be used pretty carefully. I have seen people build SaaS applications, get momentum in a SaaS application, and then start offering so much one-off customization that they're no longer SaaS almost when it's all over.
Yep.
And so they sort of undermine the entire value prop that they started out with.
Yeah, and as Robert says, release management sounds like a nightmare if you have a bunch of customizations for every customer.
Exactly why you don't want to do it.
Yep.
Yeah,
it's one deployment process for everybody. So the more complex those deployments are, the more you're sort of impacting the overall operational efficiency that you're after with SaaS.
Yeah. So Anton, you were going to say something, and then
to expand on that, right? Think about the reasons you want to build a SaaS application, right? And the reasons you want to add multi-tenancy, basically support multiple customers, multiple tenants with the single application, right? It's operational efficiency, right? It's cost optimization, it's agility. Right, you want to be more efficient as a business in general, right? That's why you're trying to see what resources, right? What assets can you share across those tenants, where your use case permits, right? So this is important. There is a reason SaaS business and multi-tenant applications grow very rapidly in recent years, right? So I would actually reverse what was said like a few minutes ago, right? When you're trying to make a decision whether you build it single tenant or multi-tenant, right? Think about the business scenario. Don't think about tomorrow. Think about, a couple of years ahead at least, right? So the two rules of thumb kind of, right, is, are there going to be a additional entity between you as a software vendor and end user? If you're thinking that there's going to be someone in the middle, like white labeling, like the scenario that we had before, yes, it makes a good sense for a multi-tenancy. Another thing that I, sometimes say is, the way cloud applications are built today is you don't need to think twice before you build it in a multi-tenant way. Think twice before you build it in a single tenant way, right? So unless you have a very good reason to build it in a single tenant way, start considering tenancy as you design your application.
Okay, we definitely got to get on to obviously the serverless part of it, but I know obviously for applications, there's a control plane element to it, and there's also a data plane element to that. How does that fit in with the SaaS and the multi-tenancy?
Yeah, we sort of have been struggled for a long time with, like, how do we describe these two halves of our applications, because we were building them and continually building with customers. We're building our own reference solutions with these, and we always saw this clear split and the line of boundaries of responsibility between what it was meant to build all the horizontal things that are needed to build, operate, manage your SaaS environment, onboard tenants, so on, and then your actual SaaS application, which was the realization of where your actual tenants are running your multi-tenant application. And so over there is data isolation and data partitioning and all these other concepts that land in your application. And so we intentionally sort of split the world in terms of how we describe it into a control plane. So in the control plane, you have identity, onboarding, you have metrics and analytics, And interestingly, in the control plane, it's actually not multi-tenant. This is all your tools that run your multi-tenant environment. It's where you log in as an admin to manage the tenants and so on. So identities in there and so on. All these things are the cross-cutting bits of your environment. And we say, if you're going to build a SaaS environment, every SaaS environment should have some notion of this control plane in it, but then draw a line between that and now, like, oh, we're going to run serverless, and we need to know, how do we provision our microservices? How are we implementing tiering? How are we routing the workloads based on different tenant profiles and so on? How are we implementing throttling? All of that lives in the application plane. And so, and those two obviously then interact with one another. Metrics data is flowing between them. Onboarding is flowing between them. But we found that this sort of this boundary between these two concepts has made it simpler for people to understand what services they really need to build to bring up an environment. In fact, what we'd say, a lot of teams want to go straight to the application plane, and they'll go, oh, we built multi-tenant microservices. We built all these moving parts in our serverless SaaS application, but we haven't built a control plane at all, right? So they're like, we're multi-tenant, we're ready to go. And we're like, you haven't built the most important part of this, which is the control plane, which is going to orchestrate all the moving parts of letting you manage, operate, onboard, and do all those bits that are part of the experience. So that's a universal term that you'll hear across all of our content is this notion of control plane, application plane. And by the way, that app plane gets called data plane all the time. We intentionally sort of avoided calling it data plane because it didn't quite map to the concept we were after. But everybody in the universe is control plane, data plane. So we're good with whatever you want to put on it. We mostly want you to have two halves here.
Because the data is data, but it's not necessarily the storing of data. There's other things.
There's your whole application is in there. Data is just one small part of it.
So, I mean, how do you then think about isolating, the data and the resources across tenants? What kind of things you can do? And I suppose that does lead into, why is serverless a great fit for SaaS? Because I can think of a few things, but I'm sure you have some more to tell me. Tell all of us.
So let me take the second part first, right? Why serverless is great for, I mean, I'm wearing serverless t-shirt, right? So I need to talk about serverless. I need to justify it, right? And Anubhav, I think we're actually addressing some of these questions like isolation, etc., in your demo, right? So
yes,
I don't want to be stealing your thunder. Okay, so think about serverless, right? And think about SaaS, right? So, once again, one of the reasons you want to build SaaS solutions is because you want to deliver value faster, because you want to optimize your productivity, because you want to have, operational efficiency, et cetera, et cetera. All of these reasons for having SaaS, they map pretty much one-to-one to building with serverless, right? So if you take a classical approach of building, for example, on virtual machines, EC2 instances, or even bare metal, right? Once you provision that bare metal or virtual instance, you're paying for it regardless how much of the capacity you're using, right? So no matter how much of that capacity you're actually using, 10% or 90%, you're paying exactly the same for it, right? And this goes obviously beyond compute as well, right? If you're managing your own database, it doesn't really matter whether you have one record there or a million records, right? You're paying for that database, right? And when you're approaching Black Friday or your next product announcement, right, or huge sales of the next Taylor Swift concert or whatever, right, you need to build for maximum, right? Because you do not want to experience failures during millions of users rushing to your website and buying whatever they need to buy, right? So you're trying to plan for maximum. I actually have a slide here, Julian. I don't know if you can share it, but yeah. So serverless is a perfect match here, right? Because one of the things that you're getting with serverless is automated scaling, right? Serverless technologies that we have, Lambda, for example, right? It will automatically detect as your environment need to scale up. For example, you have a lot of incoming requests, right? Your traffic, your traffic increases. It will automatically scale up, right? The most important thing, right, that we also need to keep in mind is as your traffic decreases, it will also automatically scale down. You don't really need to do anything for it to scale down. You do have tools for fine tuning, right? With you can control concurrency and various other settings. And I'm using Lambda as example, but obviously this can be related to other services as well, right? So the idea of serverless is since you don't need to manage the infrastructure anymore, right? You're being more operationally efficient, right? You can focus more on delivering IP, delivering value, right? It gives you higher agility. It gives you cost optimization. So you can see on this chart, the consumption will roughly be the same as your cost, scale, and performance. So serverless will adjust accordingly, right? And what we're basically saying with this slide is it's the ultimate match. All the requirements that you want to achieve under that SaaS umbrella, right? The reasons you want to build SaaS applications, serverless actually gives you that. Right.
That's really interesting because often we think of, this kind of slide for serverless, we look at it at the big picture of your organization or your whole application is able to scale up and down to manage demand. When it's quiet in the evening, your use is going to go down, and when it ramps up during the day, it's going to be busy. But it is super interesting to think about how per individual tenant within your application, this same model happens. And so in a way, also onboarding tenants, when serverless can in many cases scale down to zero, the additional cost of onboarding another tenant, which can use this kind of up and down graph, means you're also far more scalable. You're not having to set up an EC2 instance per tenant. You can, for an example, an SQS queue, it costs you, 0 cents to set up an SQS queue or 0 cents to set up a Lambda function, but that Lambda function can scale. There's SQS queues, you can add and remove them. So yeah, that is a really interesting thought, how serverless, this usage model of serverless is so applicable, not just for your application in aggregate, but per tenant.
Mm-hmm. Yeah, imagine a multi-tenant environment with shared, thus pooled sort of model, right, where we're sharing infrastructure. And I've got new tenants signing up all the time, and I've got tenants consuming different resources of my system in patterns I can't predict. And so it's almost impossible to write a scaling policy if you're off in some other environment that's going to accurately anticipate what multi-tenant environments are going to do. And this is where serverless sort of just naturally fits in there, because whatever scaling policy I need now or an hour from now, I'm not chasing that with some sort of provisioning strategy that I hope is right.
Yeah, excellent. Well, I do want to make sure we have enough time for the demo as well. Should we just switch over to that, and we can always do some questions and comments as they're coming through. I know we've had some comments via the chat about IAM permissions from Tharuka. We will certainly get to that in the demo. But yeah, just the comment from Robert Tables. Thank you again. It's easy to take serverless scaling for granted. Ever get your EC2 auto scaling wrong and instances bounce in and out of existence rapidly for very little reason? Yep, that was fun. So thanks, Robert. That's the point.
Yep.
So Abhinav, can I switch over to your screen, or
yeah,
you haven't got your bank account details or anything on? Perfect.
No, yeah. So I think a lot has been discussed in last 40 minutes, right? So I'm pretty sure people might be confused. There's a lot going on. How do I digest myself? Like, is there like a blueprint to get me started where I have the control plane built in, I have an example application plane built in, I have some sort of best practices on how to isolate tenants? Do I have like some sort of CI/CD pipeline, as Todd was mentioning about, which can just build once and deploy across all tenants, even in a silo model in a consistent fashion, right? So we had customers asking this all the time. So our team spent some time and we built a reference solution to demonstrate all those best practices, right? And I think you can share that link, Julian, if you want, for customers who want to like look at what's going on. We also then went ahead and, based upon this reference solution, built a workshop as well, right? So we actually made sure that customers understand like what it takes from step to step in incrementally building a SaaS solution, right? And that workshop had about, I would say, 7 labs. So you can obviously, in your spare time, can go through all these steps and understand what it really takes to build a SaaS solution. Starting from a non-multi-tenant solution, right? So what I'm going to do today is I will walk you through, like maybe do some quick demo and walk you through some code as well to show you some of the internal moving parts of this. And I hope that will make sense. But again, in this limited 20 minutes of time, I can almost guarantee you that we won't be able to cover up everything, but we will try our best to cover some of the basic.
So the GitHub link with the SaaS Factory reference solution, which was the link I posted first, that is the reference architecture, and then the workshop is an easy way to understand the reference architecture.
That's exactly right, because when customers started using this reference solution, they had so many questions, and then we said, okay, you know what? a step-by-step guide always helps. So we actually then build the workshop to kind of demonstrate how the reference solution works, right? So I mean, this reference solution has steps to deploy and everything, and it also have in the documentation. By the way, you have a detailed documentation if you just click on this link, but we won't go into that documentation yet. But just at a high level, if you look at the architecture, like what this reference solution kind of covers, right? So what we have is
Can we just zoom in a little bit on your browser if you
Yep,
can, just
yep,
help some people
sure.
with some smaller screens. There we go. Thank you.
Is it better?
Yeah, that's good. Thanks.
Yeah. So what we have done, we have built few web applications just to kind of simulate how a SaaS provider should be thinking while building a SaaS application, right? So typically, you need some sort of sign-up application to onboard tenants, and then in some cases, you will also need some sort of admin console to manage your tenants as well, right? So we actually built all of this using AngularJS, the UI part of it. And then we basically built a sample SaaS application, which was nothing but a demo example. We just use order and product services, just a basic e-commerce application to kind of build this application. And then on the API layer, we use Amazon API Gateway, and we implemented Lambda Authorizer for our authentication and authorization strategy. Obviously, we use Cognito as our IDP, and then we use Lambda Authorizer to authenticate tenants. And then, as we were talking about the whole noisy neighbor scenario, right? How do you throttle your tenants? So we actually leverage API keys and usage plans to do that. So we leverage some high-level some really advanced features that's built in within API Gateway to make sure that we have that all those scenarios covered while we build your SaaS solution. And then, as Todd was mentioning about those control plane, right? So we build some shared services on how to register your tenant, how to manage your tenants, how to manage your users, and also if you have to provision a separate infrastructure per tenant, we also went ahead and built tenant provisioning service that actually leverage CI/CD code pipeline to actually provision new environment. And then we went ahead and built some pooled services. I'll also show you how this tenant provisioning can also build silo services apart from these pool services, right? So I'll just walk you through that as well. And then we leverage Lambda Power Tools for some of the metrics and logging, by the way. For those who don't know what Power Tools are, they basically really help you. I got a thumbs up from Julian, so that's always good, right? So that really kind of simplifies how you log and generate metrics, right? So we actually leverage EMF format to generate metrics here. And then we also created a Lambda layer for our authorization needs, right? So that's like a high level. So
hey Anubhav?
Yeah.
I thought I'd ask you one question here. I know we're pressed on time, but I thought it's a topic that I get asked a lot. And Anton, you might weigh in on this as well. Some people will say, if you just look at compute and you talk about silo versus pool, you would say, well, every serverless function executes in its own context. So what does it really mean to have siloed compute for a Lambda function? Because they're all independent anyway for each invocation. Why do I need silo? I know the answer to this, but I thought maybe you might want to go after it.
That's a great question. Yeah. So I can take that one. So, when you're looking at the way Lambda operates, right? So each function will create its own execution environment. Think of it as a sandbox or micro VM, right? Moreover, when we need several instances of those execution environments, because your incoming traffic cannot be processed by just a single one, there is enough incoming traffic to warrant for more execution environments, we'll create additional execution environments of those functions, right? So think of them as multiple instances, multiple sandboxes of your function running. Now, each of those execution environments is completely isolated from its peers. There is nothing shared across them. Memory, disk, nothing is shared across them. So each one of them is completely isolated, which is great. And Lambda is a very ephemeral compute runtime, which means those execution environments, they're also not long-lived. They're not like, they're not going to exist for hours and days. They will be discarded after minutes, right? Depends on the usage patterns, the number differ, but they will be discarded after minutes and new ones will be created. Okay, so you can think of them, okay, so this is great, right? Those execution environments, they're providing me nice isolation, right? Because they're they're isolated from each other, right? And they're also periodically recycled, which is great. Now, one thing you do have to keep in mind, if you're using the pooled model, there is a chance that requests coming from different tenants might end up being processed by the same execution environment, right? Lambda is a multi-tenant service, so your execution environments are reused for processing different incoming events. So there's a chance, there's a probability that you have event coming from tenant A, it was processed by a particular sandbox, and 30 seconds later you had event coming from a different tenant, and it was processed by the same sandbox. So if you have some information remaining from the first event coming from the first tenant, right, that information might be contaminated, right? Your function, that sandbox might be contaminated, right, by that information, and then when the incoming request from tenant B is flowing in, right, that information is there. So there are ways to address that, right? First
Anton,
of
let me
all,
just jump in quickly. Just a caveat with that, as long as this is the same Lambda function.
exactly.
So
Not the
just,
same
yeah,
Lambda function, the same
same,
sandbox,
yeah.
same
Well, also,
instance of that Lambda function. So the
yeah,
probability is quite low.
but if you were building a SaaS multi-tenant application, and for example, you did have different Lambda functions for different tenants, this would not apply. So this
I'm
is
getting
literally,
there.
yeah,
That's
the
exactly
same
what I'm
Lambda
getting to.
function being reused.
That is
So,
exactly what I'm getting
so
to.
never think that separate Lambda functions are ever sharing anything. So that was
Yeah.
my little 2 cents
Yes.
worth.
I'm getting there. I'm getting there. Right. So there are techniques. So first of all, you need to be aware of this fact, right? That multiple requests coming into the same function might be processed by the same sandbox, right? So the general best practice, and this is not Lambda specific, it's a best practice for any stateless application, is do not store any data in your execution environment, right? Do not store data, tenant specific data globally. If you have some configuration data, that's fine, you can store it, right? But if you have tenant specific data, do not store it in global variables, for example, static or global. Do not persist tenant specific data on a local disk, right? Unless you know exactly what's the reason you're doing that, right? So the best practice here is to make sure once your function process the tenant specific data, it's all discarded. So by the time your function gets next event, there is no tenant specific data from previous events available in the context of that specific sandbox. If you're looking for even a higher degree of isolation, higher guarantee of isolation, and this is a common pattern that we do see our customers use, is you can create an instance of Lambda function, a separate Lambda function per tenant. Okay, so that's more of a siloed approach when it comes to serverless compute. So you have separate functions per tenant. It's essentially exactly the same function, exactly the same code base, right? But you deploy different functions per tenants. This way, you know for 100% that every single tenant will only hit its dedicated function. It will never ever be able to hit a sandbox that previously was processing data from a different tenant. So this is the way pooled and siloed work in a serverless compute world.
Yeah, I know
Yeah.
we need to get on with the demo because we're going to cut into all Anubhav's times, but it also say concurrency is part of that story too. So you also might want to offer better concurrency, have managed concurrency better by siloing. But go, Anubhav, you need to. I know you're never going to get through your demo if we don't
No,
stop
I
asking.
think those are all fair points, and we actually leverage reserve concurrency in this architecture to kind of limit the effect of free tier tenants over to premium tier tenants. So it's all kind of built into the CloudFormation templates as well. I mean, just carrying kind of going along with the demo, right? So right now I have in front of me my admin console, and basically, as I mentioned, we are basically using the admin console to manage and onboard tenants, right? I'm going to skip this. So typically, when you kind of log in into this admin console, you will see the list of tenants. I have onboarded few tenants already, but if you have to onboard a tenant, you will just click on this add tenant button. Just provide the name, email address, phone number, address, and plan. So I will not like go into the detail and actually enter the data in the interest of time, but I do want to point something very important, right? So we have implemented a tiering strategy in this architecture. So what that basically means, if you onboard a tenant into either basic, standard, or premium tier, they all share the common set of compute. or in other words, they are deployed in a pool model. So what that means, they use a single user pool from Cognito. They use a single API layer. They use common set of Lambda function as Anton was describing, right? So a pool model, if you onboard as a basic standard premium tenant. But let's say you have all those considerations as we were talking about. There are some requirements to have separate Lambda functions, maybe separate API gateway, right? So then you can start onboarding your tenant in a platinum tier. And when you kind of click on the submit button after you fill all these details, what really happens behind the scenes is based upon your tiering strategy, the provisioning service decides where I need to onboard this tenant in a pool model or in a silo model, right? And that kind of, if you just look at your underlying data store, goes into how your tenants are structured in a Cognito user pool or in a DynamoDB table, right? So in this case, we have this pool tenant user pool. So assume that you created a tenant in a pool environment. And in this case, we will go ahead and onboard the tenant and create a tenant admin user. So when I provisioned this tenant one, what really happened behind the scene was I created a tenant admin user and sent an email to the tenant admin saying that, okay, you have been provisioned, right? Now the tenant admin can come and add more users as well. But the important bit to note here is that we are also using certain custom attributes or custom claims to actually tell which tenant that user belongs to, right? And this kind of becomes really important in isolation strategy. So when we go into this custom authorizer and how we have implemented the Lambda authorizer inside API gateway, we're actually leveraging these constructs really heavily here. And I know it's going to take some time to get used to this concept, so it will probably be more beneficial if you just go to this workshop. But at a high level, think about it this way, that you are provisioning a tenant and choosing whether you want to provision in a pool or silo environment. And then when it comes to actually a silo deployment, we create a separate user pool. So if you see, look at here, this D3 is actually the tenant ID, which was generated when I provisioned this tenant in a silo model. And same keeps applying to your database layer as well, right? So we have this DynamoDB tables, which are shared across tenants. So as an example, we have this product pooled, and you can see, right, I have multiple tenants sharing the same table. I have tenant ID as my shard ID, and I have a suffix at the end just to kind of get rid of the hotkey partition problem in this case. So I'm kind of distributing the workload, not just my tenant ID, but kind of suffixing another random key on top of it, right? So this sharding strategy is important, right? So what we are basically doing is we are partitioning the data by tenant so that we can then apply that finite access control in this case in our custom authorizer. And also I'm sharing the same DynamoDB table across multiple tenants now, right? But in case of a silo model, we're actually provisioning a separate DynamoDB table altogether. So this order -D3 is actually a table that was created as part of the provisioning process itself. And the idea is to have a separate DynamoDB table for those platinum tier tenants.
Abhinav, does this tie into the previous question, which I did see was bringing up? Thanks, Tharuka. Any advice tips which might be helpful to provide granular IAM permission for multi-tenant SaaS? And then, what is the best practice for to adhere least privilege principles on this scenario?
Yeah, it goes into that again. So basically, now assume that you have onboarded tenants. So I'll just come to that part in a minute, Julian, right? So let's say now you have onboarded a tenant. The next thing you will do is you will kind of sign up, right? And this is where this is basically your SaaS application and how you sign in into the application. And let me just log in into the application using a tenant which I've already generated. Now you might be thinking why I am entering tenant name here, right? The reason being is that we need some sort of way to redirect our tenants to the right API gateway, right? Because now we are generating multiple API gateways for certain tenants. Customers solve this in multiple ways. You might have seen subdomain as a popular way of doing it, tenant1.myapplication.com, tenant2.myapplication.com. Or you might see sometimes when you type my name at amazon.com, you are redirected to another kind of page where you are signing in as your IDP, right, as your company IDP. So customers kind of SaaS providers solve this in multiple ways. We just ask them to provide the tenant name, and once you do that, you're basically signing in. Oops.
Did we lose Anubhav?
All right. So again, this is where now you're signing in, and there's a lot going on behind the scenes, right? And now if I just click on these products, so the question that was asked, how am I making sure that I'm only seeing the products that was created by this tenant, right? In an IAM kind of way. So you might be thinking, one way is just to put a where clause, right? Yes, you can put a where clause, but that is not necessarily gives you that guarantee. So you need a way to have some sort of permissioning, least privilege permissioning behind the scenes to support this, right? In order to show how that works, I'll probably have to jump into the code and actually show you how the tenant authorizer actually looks like. I know we only have 3 more minutes, but I'll just try to be real quick here and try to show a few things that might be interesting, right? So the first thing is, remember, we added that tenant ID as a custom claim in the JWT token, right? So when we created that user in Incognito, we actually went ahead and created a custom claim called tenant ID. Now, when I get that custom claim here in this Lambda authorizer, I'm using that to get certain details from my tenant management table, like what user pool against I authenticate, what's my API gateway URL. I mean, this is meant for some other reasons. And also my API key, which was generated as part of the provisioning as well. And then we go ahead and use STS service to create a fine-grained access role, basically. So basically what we do is that we have this policy, which I'm going to show you right here, right? So if you look at this, we have this policy which gives access to DynamoDB, but I have put this condition which says only give access to those rows which have the tenant ID as the shard ID in it, right? So I'm basically using a combination of that data partitioning strategy that we implemented in this IAM policy to create that short-lived STS credential, right? And then we go ahead and pass this on to the Lambda function. And inside the Lambda function, then you can use those AWS credentials to actually create your DynamoDB, client, which is now having those least privileges. So that's a very, very high level 2-minute kind of overview, Julian.
Thanks, Abhinav.
I can give.
Yeah, we do need to run out of time, but Todd has sent me also another link about a working serverless SaaS reference solution. So this is Todd talking at reInvent 2021. And so there's a whole video which is inside the chat and on your screen as well to talk all about that. This is fascinating. There's a workshop to look at. I posted the links earlier. I'll put that also in the show notes. There is the reference architecture to look at, to put that in the show notes. But yeah, thank you very much. We really appreciate the 3 of you joining today to explore the whole world of SaaS on serverless. Thank you very much. And just to remember next week, we always say same time, same place. It's same place, but not the same time next week. Just for time zones, regions, we need to do it. So it's going to be 3 hours earlier next week. Same place, Twitch, YouTube, and LinkedIn Live, but it's going to be 7 a.m. Pacific time. For me, that's 3 p.m. UK time. And we're going to be talking about refactoring to serverless with excellent Gregor Hoppe and Sindhu Pillai. So yeah, thanks so much, everybody, for joining. Thanks for Robert and other people who've been joining us as well, and for your questions and comments. And again, Anton, Abhinav, and John, really thanks for having time today, and we will see you another time.
Thank you.
Goodbye.
Thank you.